In this tutorial, we will be discussing how to determine the molecular formula from the empirical formula. Okay, so the molecular formula is always a whole number multiple of the empirical formula. The empirical formula is always the reduced form. For instance, if we have H2O2, that's the molecular formula of HO. The empirical formula is always the most reduced version. So for instance here, we have CH2O is the empirical formula, then the molecular formula is some number multiplied by those subscripts. We can determine what that number is that you have to multiply by looking at the molar masses. So the molar mass of the molecular formula divided by the molar mass of the empirical formula will give you a whole number, and that's what you're going to distribute throughout the empirical formula. So let's take this as an example. Fructose is 40% carbon, 6.72% hydrogen, 53% oxygen, with an empirical formula of CH2O and its molar mass of 180.2. Because they gave you the empirical formula, you don't actually have to calculate it. If they did not give you this, you would have to do the empirical formula by giving the percent composition by doing percent to mass, mass to mole, divide by small, multiply to whole. Since they gave you the empirical formula, you don't have to do that. What you do have to do is determine the molar mass of the empirical formula. So let's say we know it's CH2O. So we C, H, and O. We have one carbon, 2 hydrogens, and 1 oxygen. I got all that information from the empirical formula. Carbon is 12.0. Hydrogen is 1.0. And then oxygen is 16.0. Multiply that out. And add it together. And that comes out to be 30.0 grams per mole. Now that's the mass of the empirical formula, not the molecular formula. What we have to do now is we have to divide the two and figure out what that whole number ratio is. So we're going to take 180. This has to be given to you in the problem. The molecular mass has to be given to you. Divide by 30.0. This is from the problem. This is what we calculated. Divide those two and it comes out to be 6. So if our initial empirical formula was CH2O, we're going to multiply each one of those subscripts by 6. So C, 1 times 6 is 6. H, 2 times 6 is 12. O, 1 times 6 is 6. Let's try another one. Caffeine has the following percent composition: 49.48% hydrogen, 5.1 carbons, 49.48%, hydrogen's 5.19%, oxygen is 16.48%, and nitrogen's 28.85%. It has a molecular weight of 194.19. That molecular weight will be the very last thing that we do. So we're going to keep that till last, because that's the last step. What's the molecular formula and what's the empirical formula? You have to determine the empirical formula before you do the molecular formula. So we're going to do the empirical formula first. So let's take all of these individually. We have carbon, hydrogen, oxygen, and nitrogen. Carbon is 49.48. Percent to mass will be in grams. Hydrogen is 5.19 grams. Oxygen is 16.48 grams. and nitrogen is 28.85 grams. This is a big one, so it's going to actually be a really tight snug in the PowerPoint, so keep that in mind. So we want to convert all of these to moles before we go on. So percent to mass, mass to mole. We divide by the molar mass. So the molar mass of carbon is 12.0. That comes out to be 4.12. Hydrogen is 1.0. That comes out to be 5.19 again. Oxygen is 16.0. That comes out to be approximately 1.03. And then nitrogen is 14.0. And that comes out to be approximately 2. It's 2.06. Percent to mass, mass to mole, divide by small. So we pick the smallest number here, and that's the 1.03. So we divide every single number by 1.03. So the carbon is 4, the hydrogen is 5, the oxygen is 1, and the nitrogen is 2. Alright, so now we know what the empirical formula is. Now we have to figure out the mass of the empirical formula. So we have C4H5ON2. It went right on the bottom. Okay. So 4 times 12.0 from the molar mass gives us 48. I'm going to shorthand this because I'm running out of room. 5 times 1.0 is 5. 1 times 16 is 16. And 14 times 2 is 28. We're going to add all that together. So the mass of the empirical formula is 97 when you add that all up. So it's 194.19 divided by 97. That comes out to be 2. So that means I'm going to multiply all these subscripts here by 2. So it's going to come out to be C8 H10 O2 and N4. That is probably the hardest one you will ever find because of the fact that it starts with percentages. You have to go from percentage to empirical formula, the empirical formula to the mass of the empirical formula, divide the 2 to determine the ratio, and then multiply it through for the molecular formula. Let's try another one. This is very similar, but there's fewer elements here. Okay, so what are the empirical and molecular formulas for a compound that's 86.88% carbon and 13.12% hydrogen? It has a molecular weight of 345. Remember, the molecular weight is left to the very, very end. So we have carbon and hydrogen. We have 86.88% carbon. That comes out to 86.88 grams of carbon. So 12.01 grams of carbon, 1 mole. That comes to 7.24 moles. Then we have 13.12 grams of hydrogen. 1.0 grams in 1 mole. That comes out to be 13.12 moles hydrogen. Divide by small. So the smallest one here is 7.24. That gives me 1 carbon and 1.8 hydrogen. That's a really weird decimal place there. So what we're going to end up doing is, in order to get rid of the 0.8, we're going to multiply it by 5. That's going to give us whole numbers. So that gives us C5H9 when I do that. Alright, so now we need to figure out the empirical mass, the mass of the empirical formula here. So 5 times 12 and then 1 times 9. So 5 times 12 is 60. 1 times 9 is 9. Add those together for 69. They gave us in the question 345 is the mass of the molecule, the molecular weight. So 345 divided by 69 equals 5. That means that we're going to multiply C5H9 by 5. So that means it's going to come out to be C25H45. Huge number, but that's okay. We're going to do one last one just to make sure that we're all on the same page. Where the empirical formula and the molecular formula, if you're given the percent composition and the molecular weight. Percent composition to empirical formula. We have to do that first. So 83.625 grams of carbon and 16.375 grams of hydrogen. Carbon is here, 12.0. Hydrogen is here, 1.0. So this means that it's 6.97 moles of carbon and 16.375 moles of hydrogen. Percent to mass, mass to mole, divide by small. So I divide both sides by 6.97. Carbon then equals 1. Hydrogen equals 2.35, which is really close to 2.33. So I'm going to multiply both of them by 3. So that means my empirical formula is C3H7. C3H7. So we're started with the percentages. Convert this over to the empirical formula. Once you get to the empirical formula, you need to figure out the molar mass of the empirical formula. So 3 times 12 is 36, and 7 times 1 is 7. That gives us a total of 43 for the mass of the empirical formula. The molar mass of the empirical formula. They gave you in the question 388.78. Divided that by 43. That gives us a ratio of 9. So that C3H7 is going to be multiplied by 9. So 3 times 9, I'm at the top again because I'm running out of room, C27, and then 7 times 9 is H63. And that's how you determine the molecular formula from the empirical formula.